Hello, today I'll be showing you another Mario 64 algorithm. This one's based on RRT, which is kind of like this. So you start out with like your starting position, and then you keep on sampling a goal point like that. So you just randomly, like in this box or in 3D space, whatever, you sample a goal point just randomly, and then you get the nearest point in your RRT graph, and then you try and extend your graph towards the goal point slightly, so by a small distance. And if it hits a wall, or if like um that new segment like isn't physically possible, then the node isn't made. But if it is possible, then it gets added to the graph, right? So you just keep letting it achieve random. You keep letting it approach random goal points like this, and then you can also set your own like overall goal point like this yellow one, and then that means that um maybe like some like 10% of the time or something you can force the goal point to be that one, so you can like artificially pull the graph towards it. But it's you can also just use it as a measure of when to stop, right? Because once you reach it, then you can stop the program, right? And basically, yeah, it just like starts filling out all the space, right? Anyway, I'll just show you it. So if I run it here, you have the game here, and then this is the map thing here. It's actually 3D, but I've just flattened it so it's like a top-down thing here. And so I've manually put in like a goal point here, and then it finds like the nearest point on the graph, and then this is just a demo. So I've already computed all this. It took a while. I mean, this is a very old file, so I can't remember how long it took. I think it was a few hours or something, which is kind of crazy. But yeah, so I get it up, and then I click the X here. So this one from the map, you can see it like goes through the door, which is kind of crazy. So this is like not really AI, but it kind of is. It's just like the computer. I mean, every AI is just the computer running, but yeah, so that was pretty crazy. It just went through that wall. But if you do it randomly for long enough and with something like this, then you can discover some cool things. So after heaps and heaps of sampling, heaps and heaps of like extending the graph, you can like produce a sequence of inputs to reach that point, right? And then this one, you can see it takes a different path. So yeah, I think it's pretty interesting. Like that one just does a neat wall jump there. And what's this one? Yeah, so I put in different exit points, so kind of manually just to see these extremities of the graph, right? So this one goes up to up there, up the top of the stairs there. Doesn't take the bridge for some reason. I don't know why, but anyway, it just just makes its own way over here. Yep. And I think this is the last one where it also doesn't take the bridge, but it goes a different way. I think it's because I think it doesn't take the bridge because of the Goomba or something. Like whenever it gets hit, it would like can't it would like think of that as like a wall like being blocked. But yeah, I mean it's very interesting though.